Understanding the complete process, now we'll be jumping to the model construction. Right? First one we have the wing model. So before going to the VSP design, the introduction part is very important, right? So because when we jump to any topic, the introduction part is very important to know. Introduction in the sense the beginning section, which state the purpose and why we have to use, what is the goal of that doing that model, okay, and what is the purpose of that. So this all idea will get clear after clearing with this topic, that is the introduction to wing construction. Okay, it's like a beginning section which state the purpose and the goals of the model. That which model we have the wing model. Okay, so here wing, as we all know, bird have large feather and it's used for flapping, right? So flapping, bird moves its wing up and down when flapping or when prepare to fly like this, right? Okay, it will fold its wings, okay, uh, to generate the potential energy, and after that it will stretch back, right? Which means the complete bird, it will do flapping. Bird move its wing up and down, or before flying with bird, it will move its wings up and down. Okay, so that will create the potential energy into kinetic energy. Potential energy in the sense it will gain that energy, okay, by folding that wing, and after stretching, energy will get converted to kinetic. In the sense, bird will fly. Right. So here, the section what we have, the bird section. By looking to that, we got the idea about the wing model or wing construction, aircraft wing construction like this. Okay, like this. Right. So here, similarly for our aircraft, what we have is this one. So we have smarter wing bird like flighter. Okay. So this bird, what we have the peregrine falcon. Okay, and Lockheed SR-71 Blackbird aircraft. Okay, so this bird is the fastest bird. That is the 83.3 meter per second it will fly. And similarly, based on its name, we have the aircraft which will fly more than Mach 3. Okay, with a speed of more than Mach 3. So that is the Lockheed SR-71 Blackbird. So this is the aircraft which will fly faster than the speed of sound, that is greater than Mach 3. Okay, so it's the world's fastest jet aircraft, that is 3,500 kilometer per hour, which means 4 times greater than your commercial aircraft. The speed of this aircraft is 4 times greater than the commercial aircraft. Okay, see how the performance is varying for a different scenario, right? Which means here we have different wing section for our different birds, right? And we have different feathers for different birds like this. Okay, so based on these feathers study and bird study, what we have, like 25 different type of birds. These all 20 type of different birds have different wing sections like this, right? So quarter at low altitude, some bird will fly just on the ground, and some bird will fly at some altitude. Okay, it will not cross more than 1 kilometer or 2 kilometer altitude. Okay, which means some bird have some limitations. Okay, based on their wing. Okay, what wing they have. So based on that, even we have our different types of aircraft. Okay, and different wings. Based on the different type of aircraft, we have different wings. Okay, here we have aircraft with different type of wings and different types of aircraft. Observe. Okay, so which means to increase the aircraft performance, we have to do some alterations for our wings. Okay, so see here, different birds we have. These different birds uh, have some limitations to fly, right? Some bird will fly 25 kilometers, some bird will fly about 25 kilometers, eagle will fly faster than your parrot, right? So like this, we have different birds, and here we have duck, crow, and other birds which have their some limited range, speed, and other properties, right? So similarly here, based on this, we have different wings and different aircraft. Different wings indicates that aircraft will give some performance. Some aircraft will give good performance, this kind of aircraft, as compared to your commercial aircraft in terms of speed and Mach and all, right? Which means here wing design is very important. The alterations what we'll do. Okay, so here we have different types of wing, some like tapered leading edge, straight tailing edge, tapered leading edge, and tailing edge. Okay, delta type of wing, swept back wings, straight leading edge and trailing edge wing, straight leading edge, tapered trailing edge. So when I was discussing the wing parameter, that time I have discussed completely about the necessary of these things, right? So different type of wing will give different performance to your aircraft. Okay, so here we have different aircraft and wing with respect to the different aircraft. Okay, tapered leading edge, straight trailing edge, tapered leading edge and trailing edge, completely tapered. Delta wing shape is completely like delta. Okay, and your swept back wing and trailing edge, both are straight leading edge, tapered trailing edge, right? So here, which means the parameters what I have discussed earlier, those parameters are very important. Okay, so here this smarter aircraft. Okay, which means if we have some alterations in the wing section, then there will be lot of alterations in the aircraft performance point of view. You may generate high lift because of the change in your wing section, or because of smooth wing section. Okay, or you can even consume less fuel, right? So you can increase your aircraft overall performance by doing alterations in the wing, like different birds have different wing section, and because of their wing section and all, they have good performance to fly and to achieve their target and to fly at very high altitude as compared to the normal bird, right? Because their sections, these sections, the feather sections, different type of birds have different feathers. Okay, similarly for our aircraft, if we go for different wing section. Okay, the shape, the tapered, the sweep angle, the parameter what I have discussed during the wing parameter time. So those parameters are very important. So those parameters I'll just recap in just 5 minutes. That is the aspect ratio. Aspect ratio, as I told, that is the square of your span divided by the wing area, complete wing area. Okay, that is your aspect ratio, which means the parameters are very important. So these parameters we have, which I already discussed. Okay, wing design. If you want to design any wing, so you have to be uh, well calculated with your parameters. Okay, which means you should be well known with your all parameters, wing parameters. Okay, before designing or before modeling in any software, or before doing any real model and all. So these parameters are very important. We have the 18 parameters. Okay, that is the wing reference or platform area. Yes, complete. wing area, we'll generally call that as S, or wing reference area or wing platform area. Number of wings, how many number of wings you want, whether one, two, or three. Okay. Vertical position relative to fuselage, that is high wing, low wing, or mid wing. Okay. Which type of wing will be designing. So based on your wing design, whether you will be placing on a fuselage upper side or lower side or middle side. So that we are calling generally high wing, low wing, mid wing. So which means the positions which you'll be using to fix your wing with respect to the fuselage, right? Horizontal position related to the fuselage, cross section or the aerofoil which you'll be using, that parameter, aspect ratio, taper ratio. So here we have the complete tapered wing, tip chord. So this is our tip chord. CT is our tip chord. CR is the root chord. Okay. As I discussed, aspect ratio is the square of your wingspan divided by the complete area of your wing. That is the aspect ratio. Okay. Taper ratio. So how much taper angle you have. Okay. So based on that, you'll get the taper ratio, tip chord, root chord, mean aerodynamic chord. We can calculate mean aerodynamic chord like this. So this is your mean aerodynamic chord. If you have root chord and tip chord, so easily you can get the mean aerodynamic chord line and aerodynamic center of your wing. Okay. So 25% of your mean aerodynamic chord and 50% of your chord is shown here, and the aerodynamic center easily will get. And your span, that is B. Here we have complete span from this end to this end. That is the complete span. So that span we are generally calling small b. Okay. Dihedral angle, incident setting angle, high lift device such as flaps. Which means if you are using this kind of devices, or if you want to use this kind of devices for your aircraft, that also can be done in the open VSP. Okay. Flaps mostly we will use just to generate the high or to increase the lift coefficient, right? So that's why we will use flaps. So this that kind of high lift devices you can fix to the wing and ailerons, other wings accessories. Okay, so these are all 18 parameters has to be calculated correctly and has to be known properly so that you can go for successful wing design. Okay, or wing model. It means you can construct your model completely as per your requirement. Okay. So this is our leading edge sweep angle. This one. As we know, we have different type of wing like this. This is our completely horizontal wing. Sorry, rectangular wing. So wing loading is the weight of the complete wing to the wing area. That is the wing loading. Wing area is the wingspan into chord. So span is nothing but one end of your wing to the other end. That is the complete span. So generally we are calling that as small p. Chord is the distance from leading edge to the trailing edge of the wing. That is our complete chord length. So here we have three different wings with different taper ratio. Okay, so this type also can be done in the open VSP, which means this type of wing we can design. So this is our leading edge sweep angle. If you want to cut your section and to design one more second sweep angle, then you can do that in your open VSP, which means two sweep angle can be done for a same wing model. And here we have five wing with a different sweep angle. For this case, no any sweep angle. This case, we have the sweep angle. Like this type of sweep angle we can keep that. And this is the rectangle wing with the same platform area, but different aspect ratio, right? So aspect ratio is the square of the span divided by the wing area. So in this case, we have very high span. Okay, span this is one end of your wing to the other end. Okay, square of your span divided by the wing area. So here we have very large span length of this rectangular wing. So that's why the aspect ratio is high. Similarly, for this case, as we come down, so the span length what we have for different rectangular wing, it is decreasing. So that's why aspect ratio also decreasing. Okay, because aspect ratio is directly proportional to your span and inversely proportional to the wing area. Okay, so that's what we have the definition: square of wing area divided by projected wing area. That is the aspect ratio, or aspect ratio is the, or AR is the B square by A. So for different aspect ratio, we have different lift coefficient, which means as you increase your aspect ratio of your wing, then lift coefficient can be increased. So effect of your aspect ratio on lift coefficient versus the angle of attack for 2D aerofoil and 3D wing. So this is for low aspect ratio, and this one is for high aspect ratio. Okay, so here we have the change in lift coefficient with respect to the angle of attack for two cases. One is for infinite aspect ratio, one is for finite aspect ratio, which means for 2D case and for 3D case. As I discussed about this also, that is that weighted aspect ratio versus your maximum L by D. So here we have different aircraft with a different aspect ratio. That is the weighted aspect ratio. So for higher weighted aspect ratio, we can able to see the maximum L by D, lift to drag ratio is high for higher aspect ratio, I think. Okay, so this is the example of high aspect ratio, and this one is the example of low aspect ratio wing. Okay, so we have two wings with the high aspect ratio and low aspect ratio. Aspect ratio, easily we can tell about this aircraft. That is, the aspect ratio is very high because the span length is large as compared to this wingspan length, right? So aspect ratio is the square of your wingspan divided by area. So aspect ratio is directly proportional to your span of your wing. So that's why in this case the span length is large for this glider airplane as compared to the commercial airplane. So that's why in this case the aspect ratio is high, and in this case aspect ratio is low. Okay. So wing loading, even this also I discussed. So just a short level tell, if you increase your wing loading, which is nothing but this one, which I already shown, mass of your complete aircraft to the wing area, that is the wing loading. So total complete mass of the aircraft to the wing area, that is wing loading. So if you increase your wing loading, then you have to increase the runway length. So that's what this graph indicates. Because aircraft's weight will increase as you increase your wing loading. So that's why, because of increase in the weight, yeah, during landing case we have to even increase the runway length. If you decrease your wing loading, then the weight will be very less. Low wing loading means aircraft weight is less. So that's why for that case overall weight of your aircraft will decrease. So even we can go for a very small runway construction, right? Wing loading is directly proportional to your runway length, which means if you are designing any aircraft which is having a very high weight, so you have to make your runway in such a way that that aircraft has to land successfully and it has to stop. At the end, we should be zero, velocity has to be zero. So that's why such a huge, big aircraft, to get that v is equals to zero, runway length it will carry, no, because of that weight. So that's why here different wing loading, which means for different aircraft. So here we have different aircrafts, right? So yeah, this aircraft, and here we have different aircraft. So commercial aircraft, as we know, here we have engine, fuselage, and all other components. So if we combine all those components, if we calculate the weight, okay, or by using hanger, if we calculate overall weight of this aircraft, we'll get a high weight of this aircraft compared to the fighter jet and all, right? That's why for this kind of aircraft, because of the heavy weight, the runway length we have to increase, okay, as compared to the fighter aircraft. So here, whatever I told about the introduction part about the wing, which I already discussed while discussing about the wing parameters and all. Okay, so same thing now we have to see in the open VSP. Okay, see here we have rectangular, compound, trapezoid, triangular, okay, and trapezoid swing. Okay, which means here we have different aspect ratio for different sized wing. Okay, this is rectangular, this one is compound wing, this is trapezoid wing, triangular wing, or triangle based wing. Okay, so this kind of wing, if you need, that can be done. So this already I told, if you want to design aircraft which has to fly greater than Mach, then for that case we have to select the aerofoil, right? So thickness to chord ratio of that aircraft. Aircrafts Okay, the aerofoil's thickness to chord ratio, which will be using for your wing design and all. Okay, that aerofoil has to be in this range. Okay, for higher Mach number. Okay, if your aircraft is flying greater than Mach 1, then for that case, we have to go for the thickness to chord ratio of your aerofoil. You have to select in this range, that is 0 to 0.06% thickness to chord ratio for higher Mach, and for low Mach number aircraft, the thickness to chord ratio will come in this range, that is 12% to 18%. Okay, which means for a wing design we need aerofoil, right? So aerofoil parameter, that is the thickness to chord ratio, that is also very important, right? So now same thing I'll run in the open VSP. Okay, so here suppose I have called the wing. Today's topic is that only, right? So, okay, introduction to wing construction. So whatever I told, same introduction part I will cover here. Suppose I have selected a wing component and I will add this component. So as soon as I add, I'll get the default wing on my VSP window or main window. So this is our main window or VSP window, vehicle sketchpad window, and this one is our geometrical browser window or geometrical window. Okay, where we can take our components, geometrical components, and we can add. Now I have added wing. Okay, so after adding the wing, I got the component window. So this is the component window. Which component window? The wing component window. Okay. So now here we have the wing component related all parameters. Okay. By using this menu, you can do your wing model. Okay. In this general, we can able to see the wing name of the model which you have selected. That is the wing geometry. Okay. Now the geometry what we have the wing component, that is the default geometry with the default values. Okay, these all default values. I have not given any value, so it has to automatically VSP software given automatic values. So for this default values we have to do changes as per our requirement. That is the requirement we have to get by the calculation like this. Okay, yeah, suppose now so let me complete this. Yeah, you can even change the color of your wireframe when you can increase the resolution like this. Okay, material, so default material is there, so you can change your default material into the required material. Okay, it will not take now because the model is completely in wireframe. So what we have to do, we have to share this. After sharing we can able to see the material which we have added. Okay, like this. Okay, yeah, so if you're adding material you have to change the density and other property whatever we have in this menu, general menu. Second we have the X form. Okay, by using this X form menu you can change the coordinate system. Okay, like this, exactly where you want to place your wing model with respect to the 0,0 coordinate what we have here. Okay, so you can do alterations along X, which means you can change your location along X, along Y, and along Z. Okay, so here we have the plane X plane, Y plane, Z plane, x axis, y axis, and z axis. So this part will become completely explained. This one is your y plane, and this one is your z plane. Okay, x plane, y plane, z plane. So you can change your x location, y location, z location as per your requirement. Now I don't want to change anything. I just want to keep default. So that's why I will type 0 and I will enter. Here also I will type 0 and I will enter. Similarly, I will type here 0 and I will enter. Whatever I have done here, same now we can do the changes, that is the rotation. I can rotate the wing model along x, along y, or along z. So like this you can rotate. So why I'm telling about this option, because once you assemble the wing to your fuselage, we will rotate our wing with some angle, or we will keep with some angle of attack and all, no? So that time you can use these options. So that's why I'm telling. Okay, so if you want such kind of wing, you can do changes by using this option. Okay, and in this the model is the wing geometry model. Okay, attached and its object. Okay, so you can keep your object attached or like this normal. See this here, it's not attached now. Like this you can attach to the unattached part. So now I will just keep the default rotation by entering 0, 0, and 0. Okay. Yes, even now we have the scale. You can change your scale size like this. You can change your scale size, wing scale size. Okay, now this is our completely symmetry part, symmetry along left side and right side, right? This symmetry you can keep or you can take out by using this planar option. Okay, that is like this. Okay, if you want only x and y symmetry wing, then you can just keep that by clicking on this checkbox, xy checkbox. If you want the other plane, that is x and z, just click on the checkbox. You'll get that xy planar wing, which means the other symmetry wing with respect to xy, and similarly along yz, like this, right? Y in this direction, z in this direction, x is in this direction. Okay, see, the model is completely symmetry about the x and y plane. So here we have the plane completely x and y plane. Okay, so this is a completely x and y plane. So model is completely symmetry about that plane. Similarly, you can copy that model to your x and z plane like this. So this is my x and z plane. Similarly, you can do for y and z, which means if you need such kind of a symmetry part, you can do such things for your wing by using this option. Okay, axial. Okay, now I'll just keep as it is. Okay, yeah. Similarly, we can do the symmetry of our wing with respect to the axis. Here we have three axes, x, y, and z axis. You can take your wing symmetry section with respect to the x, with respect to the y, and with respect to the z, like this. Okay, And now you can increase the number of wings like this. You can increase the number of wings. Okay, if you want 10 wing or 20 wing, 19 wing, just type and enter that number of wing you'll get. And later you can shade like this. This is like a router right? So I don't want this thing. What I will do, just I will change the number from 1 to 19 to 1. That's it. Yeah, I use this symmetry option. That's why I got that part. So I'll just take out that symmetry. So to take out that symmetry, just click none option. Okay. Sorry. Yes. So yeah, this thing I will tell during the analysis time. So next we have the sub, that is the section. Okay. So to tell about this, what I have to do, first I have to shade this wing model. Okay. So which means for the wing, we can add the subsection by using this option. Type which type of subsection you want: surface, line, or rectangular, or elliptical. Okay, which means the control surfaces subsection, in the sense the surface control surfaces. So you can click any one of this and you can add. See here I got the control surfaces. Okay, that is our flaps, ailerons, elevators. Okay, so like lift devices and your other wing devices, you can add the minor components of your wing. You can add like this, and you can do changes to your minor components as per your requirement. Okay, like this you can increase, which means you can design the fuel tank or your ailerons, elevator, flaps, and other high lift devices. Like that you can design here, and later you can go for analysis. Width, length, and all. Theta angle, you can change the theta angle also, like this. Okay, similarly you can change the type from rectangular to ellipse, or ellipse to complete line, like this. You can add that other part, like this changes can be done. Okay, which means under this subsection we have the surfaces, that is the control surfaces, which means your aileron, elevator, radar, high lift devices, that can be added to your main wing and the tail wing part. Okay, next we have the plan, that is the span length. You can increase your wing span length. Okay, see, this is the introduction part, because once you understand the complete introduction part, then easily we can model any kind of wing as per the parameters what we have or what you will take out. So that parameter you can just input here and enter. That's it. Suppose I want to keep my wingspan 10 meter or 5 meter. Just type that and enter. That's it. Okay. Span length, chord. Even you can increase the chord length like this. I'll just convert this shaded mode into wireframe so that easily you can see the chord. Even I will take out this symmetry along XY. Yeah, yeah, okay. Yes. So in this section, we have the option, that is the chord. So like this you can increase the wing chord length, okay, or you can decrease. And the overall aspect ratio, aspect ratio will get effect if you change your chord area and span or all, okay. Next we have the root cap type, okay. Here we have root cap type flatted. We can change flatted into rounded, rounded into edge, edge into sharp, like this. See, it's getting affected, right? Like this changes can be done near the root side, okay. So that's why we have the name root cap type. This type of root cap you want to keep, you want to keep flatted, rounded, edge or sharp. Select that and change the required length of that respect to root cap type, okay. Or else you can even give offset length. Yes, even you can keep sweep stretched, okay. Similarly we have for tip, okay. So tip side, so this is our tip side of our wing. See, you can observe the changes. Similarly you can even change the length, offset, and you can strengthen your tip side. Root incidence angle you can change, and similarly incident location. And here see, here we have clusters, which means the frames, okay. So this frames or clusters you can increase like this, okay, for your leading edge. Similarly you can increase your cluster near the trailing edge, like this. Clusters you can increase near the leading edge. Observe the part what we have. So this is our leading edge and this is our trailing edge, okay. So now I will increase the leading edge clusters and I'll decrease. So you can able to see the changes. Similarly can be done near the trailing edge side. You can increase and you can decrease your clusters, okay. And next we have this section. So under section, now currently we have only one section, okay, the complete wing one section, like this. See, this box what we have completely, that is our wing section, complete one section. This section you can divide. So I'll just divide by using this option, that is split, which means you can split your wing section. So I have splitted this complete wing into two parts, that is the first part and the second part. First part is this one and second part is this one, okay. Just I'll delete and I'll show you correctly. Yeah, I'll add. I'll take out the symmetry part and I'll just shade. Okay, yeah. Now I'll show that. Yeah, this is done. Yeah, section. So now see. So now suppose your model is wireframe model. For this wireframe model, currently the wing section is completely splitted. That is completely wing, only one section we have splitted, one section, okay. uh, so this wing section what we have complete one wing section that we can split into two or three, like this, okay. See, from here to here we have one section and next we have second section and the third section like this. Okay, so this is the third section, first section, second section, and first section. So whatever changes you do here, okay, that is your span or root chord area and all, so that will get affected to only to the first section. That's it. Okay. Similarly, you can jump to the second section and you can change your parameters. Okay. See, now I will change my sweep angle for first second section. Okay, and I will jump to first section and I will change sweep angle, or I'll decrease my sweep angle. So like this can be done now. Okay, which means you can split your wing and you can do changes. So under this section we have the number of interior section. You can increase the number of interior sections like this. Inside this number of interior sections you can increase, which means number of aerofoils you can increase, and root clusters also you can increase. Similarly, you can increase the tip clusters, means the frames. Section plan form span you can increase only for that particular section which you have selected. Now currently I am on first section, no? So this first section will get changed because I am on the first section. Okay, I am not on complete wing. Okay, so just I'm on the first section of our complete wing. So whatever I will do changes the span, that will just affect to the first section. Okay, similarly root chord I will change. Now in this case, see, in this first section case, this is the root and this one is the chord. And similarly for second section, this one will become the root, okay, and this one will become the chord. Okay, root section and tip section. Okay, for section 1 this is our root section and this is our tip section. Similarly, when I jump to the second section, this will become the root chord and this will become the tip chord. Okay, now I'll jump to the third section. This will become the root chord and this will become the tip chord. And for overall wing we have, this is the root chord and this one is the tip chord. So you can do changes to your wing section. Second section you can do root chord changes, or you can even do changes to your tip chord like this. Now I'll jump to third section and I will increase my root chord little bit and I'll increase the tip chord, or I will increase like this. Okay, and sweep angle, if you want to increase, you can increase the sweep angle for the third section like this. Sweep location also you can change where you want to locate your sweep, and twist angle. Okay, you can twist your wing, like you can twist like this. You can jump to second section, you can twist. Okay, and twist location also you can change. Okay, and you can change your twist and dihedral. Okay, now next we have the aerofoil. So for this case, yes, okay. Yeah, so see, in this section we have the aerofoil, which means we can add any aerofoil as per our requirement. Okay, you can choose the series, whether you want circular, elliptical, super ellipse, or rounded rectangular, or general. Okay, or 6 series, or 4 digit, or 16 series. So select any required aerofoil. I'll select 5-digit aerofoil. Okay, just yes. Uh, See, for 6 digit we have the parameters with respect to the 6 digit. Okay, similarly, if we select the 5-digit aerofoil, then with respect to 5 digit we have parameters, that is thickness to chord ratio. Okay, ideal cl, camber location. Okay, and if I select 4 series aerofoil, then for 4 series the respective parameter will get, that is thickness to chord ratio and camber. Okay, so you can add your thickness to chord ratio, see, like this. I'll change my thickness to chord ratio. Yes, can able to see the changes. Similarly, you can increase the camber or you can decrease. Or if you know your thickness to chord ratio of your aerofoil and the camber location and camber length, which means the thickness, then you can type and you can just enter. Okay, or else you can even directly preview that aerofoil like this. Just click on show, you can preview aerofoil like this. Okay, if you want to do changes, then you can alter your aerofoil and you can observe the changes here. See, I have changed my aerofoil from aerofoil section to the circular section, elliptical section, rounded, rectangular, like this, as per your required parameter you can add, which means whichever aerofoil you need for your wing model, that aerofoil you can select and you can design your wing model. Just I'll select 4th series and I will maintain normal camber. Okay, yes, so in this you can change your complete aerofoil. Okay, next now blending and okay, blending and modifications you can use especially for aerofoil. Okay, you can change your angle, theta, scale, shift and all. So these things will not use much, but if you need you can do changes. Okay, for your wing tailing edge, side edge, you want to keep edge or rounded or sharp and all. Okay, similarly you can trim your part, leading edge side and tailing edge side, you can do changes. Okay, so this is all about the wing. Okay, after doing the changes and all, you can shade and you can able to see your wing model like this. And for this wing model you can change your material. Just come to general and change the material from default to the aluminum based or your rubber based or glass based or silver based, gold based, bronze based, any material you can add. And you can able to see this is your complete wing model. As soon as you complete your wing, then just go to file, go to save or save as, and give your file name model 1 model wing model, and accept. Choose your path. If you want to save in a C drive or E drive, choose your path and just accept. Give proper file name and accept. Your model has been saved successfully. Okay, so this is all about the introduction part. Okay, so he introduction to wing construction. This is how we will do in our open VSP. So here I will stop. Thank you all. We will continue tomorrow. Hello.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Okay, thank you. Good evening. Okay, bye. Good night.
Good night, sir.